Proof by induction, let's go. So we're asked to show that 4 times 8 to the n plus 66 is divisible by 14 for all integers n greater or equal to 0. Let's look first of all then n equals 0. We're going to get 4 times 8 to the 0 plus 66, which is 70, which is then equal to 14 times 5. So this is true. You might write true for n equals 0. I normally just do a little tick, but if I'm doing an exam, I should probably write a little bit more. Next up, I'm going to assume. So we've shown that the first domino falls over. We're now going to assume that the n equals k domino falls over, and that pushes the next one over. And then we can say that they're all going to topple over. That's essentially the idea behind induction. So assume true for n equals k. So 4 times 8 to the k plus 66 is equal to 14a, for example, where a is an integer. And we're going to aim to show true for n equals k plus 1 using n equals k. Okay, so that means that 4 times 8 to the k plus 1 plus 66. Now I need to somehow use this to help me. This is going to equal 4 times 8 times 8 to the k plus 66. I'm doing that because I want the 8 to the k. I want to try and somehow get 4 times 8 to the k plus 66. At the moment, I have 32 times 8 to the k plus 66. So I can just take 28 of them and then add that separately onto the 4 lots of 8 to the k plus 66. I'm separating it, and now this here is my 14a. And I've got a common factor of 14. That's what I wanted. So it's 14 lots of 2 times 8 to the k plus a. This is divisible by 14. And we're basically there. So true, I'm just going to write this again. I know we said it above, but true for n equals 0. And n equals k true implies n equals k plus 1 true. I tend to then write by the principle of mathematical induction. Statement is true. Maybe I'll write the statement out again, actually. 4 times 8 to the n plus 66 is divisible by 14 for, was it integers n greater than 0? For all integers n greater or equal to 0.